Your car's engine is a powerful machine. It creates the force that moves you down the road every day. To do this, it must get hot. This heat is a normal and necessary part of its operation, but there is a very important limit to how hot it can get. When an engine gets too hot, serious problems begin. This condition is called overheating, and it can cause massive damage. This damage can be expensive to repair. It can also leave you stranded on the roadside. A simple, yet brilliant system prevents this from happening. At the heart of this system is the radiator. Let's explore why engines get hot and how this crucial system keeps them safe. Under your car's hood, a constant battle is being waged against heat. When that balance is upset, the temperature inside the engine can rise very quickly. An internal combustion engine is essentially a heat engine. Its entire purpose is to convert the chemical energy and fuel into the mechanical energy that turns the wheels. This process begins with a mixture of gasoline and air being drawn into a small enclosed space called a cylinder in Troitekdawi, and dan dosonan sau rin cylinder intake and say. A piston then compresses this mixture. Compression, a spark plug ignites it, power. This ignition creates a small, controlled explosion that pushes the piston down with great force. This happens hundreds, or even thousands of times every minute your engine is running. Each one of those tiny explosions generates an immense amount of heat. Temperatures inside the cylinder can briefly reach over 4,500 degrees Celsius, or about 2,500 degrees Celsius. While much of this heat becomes useful work, a significant portion is absorbed by engine metal, cylinder walls, piston, cylinder head. This is the primary heat source the cooling system must manage. Without removal, temperature would rise uncontrollably until parts fail. Heat is also generated through friction. Many metal parts move at high speed, rubbing together. Even though oil lubricates these surfaces, friction is still present. Friction resists motion and generates heat. This adds another layer of thermal energy to the engine block that must be dissipated. The faster the engine runs, the more explosions, the more friction, and more heat. A warm engine is actually more efficient than a cold one. Ideal operating temperature, between 195 and 220 degrees, about 90 to 104 degrees. Fuel vaporizes more completely, combustion is more efficient, engine oil flows more easily. The challenge is to keep heat within a very specific optimal range. The cooling system is designed not just to cool, but to regulate temperature with precision. When an engine's temperature rises above its designed operating range, the metals it is made from begin to behave differently. Extreme heat causes metal to expand. If it expands too much, precisely machined parts can lose their shape. The cylinder head is especially vulnerable. If it gets too hot, it can warp. A warped cylinder head will not sit perfectly flat against the block, creating gaps and causing the head gasket to fail. This is a very serious and expensive repair. A failed head gasket can trigger a cascade of other problems: loss of compression, fluids mixing, hot combustion gases can be forced into the cooling system, or coolant can leak into the cylinders. Coolant can mix with engine oil, turning it milky and sludge-like. The contaminated oil fails to lubricate properly. Bearings can be destroyed, leading to complete engine seizure. Rubber hoses can crack, plastic tanks can split, various seals and gaskets can deform and leak. Engine oil works in a specific temperature range. Overheat it and the oil breaks down chemically. The coolant can boil. Once it becomes steam, it cannot absorb heat effectively. Pressure can rise and burst hoses or the radiator, spraying scalding steam and fluid. A cracked engine block with visible damage from overheating. These smaller failures can cause overheating, or be caused by it. Understanding the fundamentals is the first step toward preventing it. To prevent catastrophic damage, every water-cooled car has a dedicated cooling system. A special fluid absorbs heat from the hottest parts of the engine, carries it to a different location, and releases that heat into the surrounding air. This continuous closed-loop cycle keeps temperature stable. Coolant, typically a 50-50 mix of distilled water and glycol, raises boiling point, lowers freezing point, and adds corrosion protection. The water pump, a centrifugal pump driven by the engine, moves coolant continuously. Coolant flows through water jackets around cylinders and combustion chambers, absorbing heat from combustion and friction. The thermostat is a temperature-sensitive valve, closed when cold to warm up quickly. At 195 degrees Celsius, 90 degrees Celsius, it opens to send hot coolant to the radiator. The radiator is the centerpiece and primary heat exchanger. Hot coolant enters the top tank, flows down narrow tubes woven with thousands of aluminum fins that spread heat across a massive surface area. Strategically placed behind the grill, airflow passes through fins and carries heat away. Convection. As fins cool, they cool the coolant inside the tubes. By the outlet, temperature drops significantly. The water pump sends cooled fluid back to the engine to repeat the cycle. When the car is not moving, there is no natural airflow. This is why cars are equipped with 1 or 2 electric cooling fans mounted behind the radiator. Controlled by temperature sensors, fans switch on when coolant gets too hot and off as it cools. Together, coolant, pump, thermostat, radiator, and fans regulate heat precisely and protect the engine. Your car will almost always give you warning signs before serious overheating, a rising temperature gauge or a warning light. Steam from under the hood, often called white smoke, means boiling coolant escaping under pressure. A distinct sweet smell is ethylene glycol. Leaking coolant contacting hot parts. Performance can suffer. An overheating engine may feel sluggish or hesitate. You may hear pinging or knocking from improper ignition in hot cylinders. Puddles of bright green, pink, or orange fluid under the front of the car indicate a coolant leak. A low coolant overheat can make the heater blow cool air. A very hot engine can make it blow extremely hot air. If the gauge rises or the light comes on, reduce engine strain. Turn off your air conditioning immediately. Do the counterintuitive. Turn the heater to maximum heat and the fan to high to shed engine heat. Find a safe place to pull over as soon as possible. Turn off the engine. Let the engine cool naturally, at least 15 to 30 minutes. Look for leaks or damage from a safe distance. Never open the radiator cap when hot. System pressure can cause scalding eruptions. After it cools, check the reservoir level. Add coolant or water in an emergency. If leaks are major or it overheats again immediately, call a tow. The best way to deal with overheating is prevention. Once a month when the engine is cold, check the coolant reservoir, level between min and max, top off with the correct coolant specified in your owner's manual. Consistently low levels mean a slow leak. Coolant ages. Additives break down and contaminants build. Flush and replace per schedule, often every 30,000 to 100,000 miles. Inspect hoses. They should not be mushy, brittle, or spongy. Look for cracks, bulges, rubbing, and check clamps for tightness. Keep radiator fins clear of leaves, bugs, and plastic. Clean gently with a soft brush and water. Thermostats and water pumps wear out. Watch for sticking temps, whining or grinding, or a weep hole leak. Have a pro replace as needed. The cooling system is the unsung hero balancing necessary heat and destructive heat. Coolant carries the heat, the pump moves it, the thermostat gates it, the radiator and fans dissipate it. Repeat. Recognize. Early warnings. Rising gauge. Sweet smell. Mysterious puddle. Steam from the hood. React quickly. Small, proactive steps protect your investment and ensure safety and peace of mind every time you drive.